Hello friends, welcome to Level Up System Design, the only channel you ever need to follow to crack system design interviews at FAANG or any other top tech companies. This is the first video of the Level Up System Design Basic series. In this video, let's learn about what is a system before we actually set out to design a system. And in that context, specifically, we will be discussing what we call an online service. Most of us are familiar with coding. We know how to write a small piece of code to perform a simple operation. That code could be a simple lead code problem that you're working on. This code is a program that takes an input and generates desired output. A simple example of such a program is sorting. There are many ways to sort a list of items. So before we write the code for sorting, we usually first determine what sorting algorithm we want to go with. Based on that algorithm, we also determine what specific data structures we want to use. Once we decide on the algorithm and the data structures, we code it up. This sorting program runs on a machine we are logged in. This machine has two main components. One is a CPU, the other one is the memory. For every algorithm, we perform an asymptotic analysis. That is, we talk about the time and space complexity of the algorithm we designed. In other words, this analysis tells us how we use the CPU and how we use the memory when this program runs. Typically, the size of the input to any program is denoted by n. We quantify the rate of growth of time and space based on this input size. In the case of sorting, we can assume we use one single CPU, and we also can assume that the data is going to fit in entirely in the memory. Let's take merge sort as an example. The big O analysis, which is the asymptotic analysis, shows us that the merge sort takes O of n log n time complexity, and it also requires O of n auxiliary space. In systems design, we convert our standalone program into an online service. Let's just understand what does this mean. Imagine now the users of the program are residing far away from you and me, and they want to execute this program over the network. That is, the users are now logged in on another device. For example, it could be another machine. A request is sent to the program remotely. The program executes on this machine and then sends the output as a response to the user. Thus, this becomes an online service. We call these programs application programs to differentiate them from operating system programs. Application programs take care of users' requests. We can also call it an online service as it provides service over the network. These services accept a request and return the result to the user as a response in a specific format. Machine that runs our program or online service is called a server. User machine that sends the request is called a client. The client can be a browser, or it can be a desktop app, or it can be a mobile app. Client sends the request to the server, and the server can do a lot of sophisticated logic and sends the response back. Server program is actively listening for client requests as if in an infinite loop. As soon as the request is received, it executes the program, computes an output, sends the output to the client as a response, and again listens for the next request. The server is like a black box. The client only knows the interface to the program, but the internal implementation is not visible to the client. The client only knows the interface to the program, but the internal implementation is not visible to the client. This public interface is generally called an API, application program interface. This API exposes the behavior of the program to the clients, but hides implementation of the program. The API defines the format of the request and the response to the client. In addition, there could be some definition of semantics for error scenarios as well. For example, a 404 error for HTTP requests when a particular resource is not found. This service can be a very simple service or a very complex service. Now let's define what is a system design. A system design is a set of components which interact with each other to provide an overall functionality via its interface. The black box can encapsulate several components to provide this service. Each of these components in itself can be a simple component or can be a complex system, but is just a component in the larger system. For example, let's take a binary search. Binary search requires input to be sorted. If we want to provide binary search as an online service, it can incorporate two components. First, a sorting component or a service, and then the actual binary search service itself or the logic itself. The sorting service could be an online service that clients can use on its own, like we talked before, and as well as a service used by the binary search service. So there could be an online binary search that users would talk to, and this binary search would talk to the sorting online service internally. So this binary search would use this online sorting service internally, and so this service is actually a component of this binary search online service. Thus, this together becomes a binary search online service to the users. At the basic level, in other words, at the lowest level, every system is composed of three units. One is CPU, the second one is memory, the third one is communication channels which link together the compute resources and the storage resources. CPU provides computing service, that is computation. Memory provides storage service, and communication channel transfers bytes from one place to another. It could be a service bus within a single machine, or it could be a communication of data from one machine to another machine that sit far apart. In larger scale systems, there could be several machines with multiple CPUs, with multiple RAMs, with different communication channels, all of these working together as one coherent system to provide a service to the client by generating a response to the request, preferably in a short amount of time. The response time should be kept as small as possible. As a service becomes popular, there will be millions of users or clients requesting the service. And our system should be able to handle that traffic, maybe millions of requests per second. If our system can handle it, we call that a scalable system. Please refer to another video in this basic series to learn about scalability. Today, many applications are data intensive as opposed to compute intensive. CPU capacity is rarely a concern for applications. Usually the problem is with the amount of data, the complexity and the speed at which the data is changing. Here we talked about online systems mostly, but there are other systems such as batch processing systems and even streaming systems. We will cover these in detail in other videos. That's it about a system. Thank you so much for watching this video. You are now one step closer to achieving your goal. Please like, comment and subscribe to this channel. See you soon.